Hello, good morning viewers. In today's tutorial, I'm going to introduce the topic SURD, and we're only going to discuss about three things under SURD: definition, types, and rules. But before we start, I would like to let you know that I have activated YouTube membership of my channel, where active subscribers can decide to be part of my community. It is as simple as clicking the join icon next to the subscribe button. And you can do this for two reasons: one, to support the channel, and secondly, to subscribe to my exclusive content. And there are two available options there. The minimum is 1,000 and the maximum is 10,000. Thank you for all the support. Now let us begin. I would like to let you know that SURD is a number. So if it is a number, let us refresh our memory on our previous lesson. If you could recall, when I introduced the topic numbers, we categorize these numbers into two. We say there are real numbers and there are imaginary numbers. We are not going to talk about imaginary numbers because our SURD is under real numbers. These real numbers, we say they are categorized into two also. We have rational and we have the irrational numbers. Our SURD falls under here. But let us talk about rational numbers first. You know, rational numbers are those numbers that you can express as a ratio of two integers. 2 is an integer, 5 is an integer, so this is a rational number. 5 is an integer, also a whole number. It's a rational number because you can rationalize it as 5/1. A decimal number 0.5 is a rational number because you can express it as a rational number, which is the same thing as 5/10. So all those numbers you can express as numerator over the denominator are said to be rational if and only if the denominator and the numerator are all integers. But irrational numbers cannot be expressed as such, and we have cited so many examples on why they are irrationals. Once you try to express an irrational numbers in this form and simplify, you are going to get a decimal number, which is a non-terminating one. It has non-terminating decimals. Example, we have pi. Pi is an irrational number, but it is not a SURD. A number like maybe 2.345 continuously, non-terminating, it is an irrational number. E is an irrational number. Square root of example 2 is an irrational number because once you try to simplify this, you're going to get roughly 1.412 in that order. Since it has a non-terminating decimals, it cannot be expressed as rational, so it is regarded as irrational. Cube root of 5, if you simplify it, you get non-terminating decimals, so it is also irrational. But a number like square root of 4 will fall under rational because this can be written as 2, which is a whole number. So if we are talking about square root of a number, for that number to fall under rational, it must be a perfect square, but otherwise it will fall under irrational. So this SURD is talking about all those irrational roots. So square root of 2 is irrational. Cube root of 5 is also irrational. So these two are examples of SURD. But square root of 4 is not, because you can simplify it to 2. Take your calculator and hit these values. You see non-terminating decimals, so they are regarded to as irrationals. So now, can you figure out the definition of SURD here? So SURD is just the root. That root can either be square root, cube root, fourth root, in general, nth root of a rational number, and that rational number must be positive. So let me write the definition for you. We say SURD is the root of positive rational numbers. Example, we have square root of 2, cube root of 5, nth root of a. This is the general form of a SURD, nth root of a, where a is a rational number. You know, n is the degree or the index. This is the radical sign, while this a as a rational number is termed as the radicand. But in this tutorial, we are going to center the discussion based on square roots of non-perfect square numbers. So all these numbers, let us start with square root of 1, square root of 2, square root of 3, square root of 4. So all those that cannot be simplified here to a whole number, they are termed as the SURD. This can be simplified to 1, but this cannot. This cannot. This is equal to 2. This is equal to 3. So this is a SURD. This is SURD, 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 SURD. You understand? All those that cannot be simplified to a whole number, they are termed as SURD. Okay, moving on to types. I have summarized all these things. They are here in my tablet. Moving on to types. We have so many of them here. We have pure SURD, we have mixed SURD, we have monomial, we have binomial, we have trinomial, and so on. Conjugate, we have conjugate SURD. I think we can stop here. Let me discuss about these fundamental ones. A pure SURD. SURD is said to be pure if and only if it contains only one rational number. Example, square root of 2, square root of 3, square root of 5. They are all examples of pure SURD. Mixed SURD. A SURD is said to be mixed if it contains more than one rational number. Example, if we have 2 root 3, you see we have a rational number here, we have another rational number here. This is a SURD combined with a rational number. So this is an example of a mixed SURD. 3 root 5, they are all mixed SURDs. Or example, we may have another one, maybe root of 2 root 5. You can see them. All this one is mixed SURD. Now let us talk about monomial. Mono, from the word mono, it means one. Once you have a single SURD, it is termed as mono. Binomial, when they are 2. Example, you may have root 2 plus root 3. This is binomial. Trinomial, you may have root 2 plus root 3 plus root 5. This is trinomial. Conjugate. Conjugate of two surds are said to be conjugate of one another if and only if they only have a difference of sign, either positive or negative. We are not talking about multiplication and division here. Let me give you an example of conjugate surd. If you have root 2 plus root 3, it is conjugate to root 2 minus root 3. You can see that they only have difference of sign, but we have root 2 here, we have root 2 here, root 3, root 3. So these are conjugate. Or maybe you can have root 3 minus 5, root 3 plus 5. They are said to be conjugate of one another. If you are asked to find the conjugate of this, just give this, and vice versa. Likewise, if you are asked to find the conjugate of root 3 minus 5, just say it is root 3 plus 5. Or if you are asked to find the conjugate of root 3 plus 5, just say it is root 3 minus 5. Moving on to rules. Let us talk about rules. Rules. Let's talk about multiplication first. Multiplication of surds. When you have two or more surds multiplying one another, suppose you have surd A multiplied by surd B. This can be written as surd AB. You can multiply surds together, you can divide them, but you cannot add or subtract them unless if they are similar. We are coming to that. Similar surds. I even supposed to include it in types of surd. Similar surd. Surds are said to be similar if and only if they have a common surd. Suppose we have 2 root 2 and we have root 2. We have 5 root 2. You can see the roots are the same, so they are said to be similar. You can add them. But otherwise, if you have root 5 plus root 2, they cannot be joined together. They will remain like this. I'm coming to this. I'll explain this in details. This is in general. Example, if we have square root of 4 multiplied by square root of 9. This can also be written as square root of 4 multiplied by 9. Let us simplify them separately and see whether the result is the same. You know the square root of 4 is 2. Square root of 9 is 3. Is this the same thing as this? Because this is a square root of 4 times 9 is 36. 2 times 3 is 6. And square root of 36 is 6. So if you have two surds, they can multiply one another. So what about if they are mixed surds? Suppose we have A root B multiplied by C root D. This is the same thing as AC root B BD. If you are multiplying mixed surds, multiply the rational numbers separately. A and C, they are rationals, and you multiply the surds separately. This is how to multiply surds. Do not include the rational numbers in the surd. Example, suppose we have 2 root 4 multiplied by 3 root 9, just like this one. You can take the rational numbers, multiply them separately. It is the same thing as 2 times 3. Then times square root of 4 multiplied by 9. This one outside can be 6 times, you know, we have simplified this to be equal to 6. You see, altogether we have 36 here. The same thing, you know, root 4 is 2. 2 times 2 is 4. This is root 9, which is equal to 3 times 3 is 9. And this time this is 36. You can see 36 equal to 36. So this is about multiplication. Now let us move on to division. Division. Division of sorts. Division can be done simultaneously. If you have root A divided by root B, in SURD, this can be written as root A over B. Sometimes this A and B might appear to be non-perfect, but maybe dividing A by B will seem to appear to be a perfect number, and you can easily take the square root of a perfect number. This is one of the advantages of dividing this. Suppose we have square root of 9 over square root of 4. You know, this is the same thing as square root of 9 over 4. 9 over 4 cannot be simplified, so taking this is more appropriate than this. And this is equal to 3 over 2, because the square root of 9 is 3, the square root of 4 is 2. Once you cannot simplify them, just take their square root separately. So you can even take it from here without even transforming them into this form. But if they can be simplified, it is always better to do that. Let me give you an example. Suppose we have square root of 8 divided by square root of 2. 8 and 2 are non-perfect numbers, so our answer will remain like this forever. But with the help of this rule, we can combine them as square root of 8 over 2. And you know that 2 is a factor of 8, so it can go there without remainder. So we can write this as square root of 4. And square root of 4 is 2. So you see, sometimes the numbers under the square root are non-perfect numbers. But by simplifying them, you'll be able to obtain a perfect square number, which you can easily take the square root of. But let us look at addition and subtraction and see whether the result will be the same. For addition, suppose you have root A plus root B. This is never equal to root A plus B. Please do not join them together. They cannot be joined, because suppose we have square root of 9 plus square root of 4. Let me show you. Suppose they are the same. 9 plus 4. Square root of 9 is 3. Square root of 4 is 2. Is this equal to square root of 13? 13 is not a perfect square number, so you cannot take the square root of this. So it will remain like this, because there are no any other two exact numbers that you can multiply together to get 13. You can see this is equal to 5, and 5 is never equal to root 13. So please do not join them. If you are talking about addition, do them separately. But if they are like terms, similar sort, example, if you have root A plus root A, you see they are similar. All the two terms are similar. So this can be written as 2 root A. Suppose you have an apple and another apple, you have 2 apples. If they are similar, suppose we have 2 root A plus 3 root A. 2 apples, 3 apples, making 5 apples. If they are similar, you can join them. If they are not, you can never join them. Similarly, if you're talking about subtraction, let us talk about subtraction. If we are to subtract root B from root A, this is never the same thing as A minus B. They are never the same place. Again, if we are subtracting, it is never the same as say 9 minus 4. Because here we have 3 minus 2, because square root of 9 is 3, square root of 4 is 2, 3 minus 2 is 1, and 1 is never the same thing as 9 minus 4, you know, is 5. This is 5, this is 5. They are never the same, please. If you are subtracting, from here you can see root a minus root a will give us 0, because they are exactly the same. Once you have an apple, you take away that apple, you have nothing. Again, here, if you have subtraction here, you know, you have 2 apples, but you take away 3. How comes? So there is a depth of 1, which we call negative. So there is negative root a. Just like saying 3 minus 5, you know, is equal to minus 2. Once you subtract bigger number from a smaller number, the result must be negative. So I think we can stop here. Subsequently, we're going to be solving problems under SURD. So thank you for watching. Do have a nice day.